10.6, surface areas of pyramids and cones. And you can deal with my pictures because I tried to draw pyramids, so they're close enough, okay? A height of a pyramid, okay? There is something called a height and something called a slant height on pyramids and on cones. They are different. We need to talk about them. The height of a pyramid is the perpendicular distance between the base and the common vertex. Yes? And then, yes, just look. Okay, so here is my base on this pyramid. Here's my vertex. The height is the perpendicular distance from here to the base. Okay, so it's almost always inside of my pyramid. Well, it is inside my pyramid. So if I have a pyramid, my perpendicular bisector goes from there down to this base. Okay, it's that line inside of there. Okay, which creates, actually, let me do this, a triangle for us. So if I have this perpendicular bisector from the vertex to the base, I create a triangle with that opposite side. Do you see that? There's that. There's that. See how I have a triangle now going on? And then this part here, that is the slant height of a pyramid, is the height of any of the triangular lateral faces. So the slant height is the height of these faces, which is the hypotenuse of this triangle that's created there. So if I can have the height of the pyramid, or if I have the slant height of the pyramid, I can find the other. Okay? So, a regular pyramid, the base is a regular polygon. Okay? So it's a square, it's a octagon, it's whatever, but it's a regular polygon. Okay? And all the lateral faces are congruent, and they are isosceles triangles. What does isosceles mean? The two sides are equal. So these four faces here are isosceles triangles, meaning these two side lengths are equal. Okay? So I can start to solve things. Okay? The pyramid at California State University, Long Beach, has a height of 192 feet. The base of the pyramid is a square with a side length of 345 feet. What is the slant height of the pyramid to the nearest foot? So I'm trying to figure out what this L is here. That's how they represent slant height, is by a cursive L. How can I figure that out? What do you think we can use? So look, you have this height, right, at 192. I have this base, or I have this right here at 172.5. How did I get 172.5 for that? Because it's not in my instructions. How do you think I got that? What is the length of this side here? What's half of 345? Well, are you sure? I could be leading you wrong.
172.5.
Okay, so because this line is drawn from here to there, it's a perpendicular bisector, which makes this 172.5. Okay? So how can I figure out what this part of that triangle is? What? Nope, nope,
Would it be one half of
Nope.
192? It would be 192 because it's the same thing.
you wanted,
Wouldn't it be the same
Uh-oh.
thing as one?
I have a question. If I take away everything and just have this triangle here that's in maroon, I have this type of triangle. I know that this is 192. I know that this is 172.5. How do I figure out what that is? No. Angles equal 180.
360.
No. 360 would be angles for a square. Don't think angles. Yes. What is that called? Pythagorean theorem. A squared, B squared, C squared. So I have to set it up to say 192 squared plus 172.5 squared equals L squared. What's 192 squared?
36,860.
36,000? And then what? 864. What is 172.5 squared? And yes, you'll probably have a decimal.
2975625.
29756. Then what? 0.25. What are those two things added together? 66,620.25 equals L squared. So I take the square roots of that number. And what do you get? And it says round to the nearest foot. Okay, 258.1, which means when it says round to the nearest foot would be 258 feet. Okay, so, like I said, yeah, that's all you have to do, that's the answer. So like I said, when you have the height of the pyramid, I can always find the slant height of the pyramid because I can use Pythagorean theorem. And when I have the slant height of the pyramid, right, when I have this, I can always find the height of the pyramid because I can use Pythagorean theorem backwards, yes? Okay, or I can find the base because this portion here that goes from here to here is half of my base. Okay, because we split it in half. So we can always work those backwards. Now, the next thing is surface area. There is a formula for surface area for pyramids. It is surface area equals, this stands for what? Do you know? The area of the bases. If you have a big B, it stands for the area of the base. Okay? So this is the area of the base. Okay? Plus, what do you think that P stands for? Perimeter. Plus 1/2 of the perimeter. And what's that L stand for? The slant height. Okay? So perimeter, slant height. Okay? When we are dealing with pyramids, that cursive L stands for slant height, not for length. So it says find the perimeter and the area of the base. What's the perimeter of this base? What shape is that base? I know it looks bad, but what shape do you think it is from? No. Square. You have a pyramid. So you have a pyramid.
So we're looking with.
The base is this right here. Boom, boom, and then this portion of the square here.
Are we just looking at the bottom?
Yes, when it says find the perimeter. When it says find the perimeter and area of the base, you're looking at the bottom of your figure. So what's the perimeter? 40 what?
Centimeters.
Okay, and what it would be the area then? 100
100 centimeters.
centimeters squared. Okay, you should be able to do that. Okay. Then we're going to find the surface area. Well, look, I already found the area of that base, and I found the perimeter of that base, so I have to just plug it into this equation. Okay, so surface area equals that big B, which is what? 100 centimeters squared. Plus 1/2 of, what's the P? 40 centimeters. And then times what? 13. Good, that's the slant height. Good. Times 13 centimeters. What is 13 times 40?
120.
And then divided by 2.
260.
Plus 260 centimeters squared. So 260 plus 100 is 360 centimeters squared. Okay? So basically, when we're finding the area of this stuff, we're just combining like knowledge that we already have. If we do not have the slant height, they would have given us the height of the pyramid, and we would have had to do Pythagorean theorem first to find the slant height and then plug it in. Okay? So if they don't give you the slant height, you have to find it. Height of a cone. Okay, so I have a cone, right? Cone also has a height and a slant height. The height of the cone is the distance between the vertex and the center of the base. So the base on a cone is always what shape?
Circle.
A circle. So the height of the cone is once again inside of it, from the vertex there to the bottom of that circle, which is going to hit where on the circle? The center. Yeah, the center of my circle. Okay? So then it's going to create, if it hits the center of the circle, that means from there I can draw a line out here, which is the what of the circle? Radius. And then I can find my slant height still by using Pythagorean theorem still. Okay? So the height of a cone is the distance between the vertex and the center of the base. The slant height of a cone is the distance between the vertex and any point on the edge. So my slant height, I can have several of them on here, but it's anywhere from this vertex to the edge of the cone. Okay? Okay. So formula for surface area for a cone is the surface area equals, once again, what's that big B stand for? The area of the base plus pi times my radius times my slant height. Now, the area of a base of a circle is always what? How do you find the area of a circle? Pi r squared. So you're going to see this formula written this way instead. Surface area of a cone is pi r squared plus pi times r times L. So what are the two pieces of information I need to solve the area of the surface area? Nope, you don't need the base.
The R and
the R. I need the radius and I need the slant height. Because I have this formula broken down far for me, so all I need is the radius and slant height. Okay? Now, find the surface area of this cone. Round to the nearest square inch. How can I find the surface area of a cone that's labeled like this? How do I set it up?
S equals pi times
7 squared plus pi times
7
beautiful. What's 7 times, 7 squared is, so I'm going to leave this like this for a second. I have 49 pi, okay? I'll multiply it in a minute once I add it all together. I'll show you why it makes it easier. What's 7 times 24? What is it, 160 what? 168 pi. Now look, it makes it easy because I can add 168 and 49 together. What's 168 and 49?
217.
So I get 217 pi. Now, just do 217 times pi, and you've saved yourself some time for rounding. 681.7, and it says round to the nearest square inch. So what's the nearest one?
682
inches squared. Does that make sense? Okay. So that is what you're doing on your homework tonight, surface area of pyramids and cones. And that is 10.6. I will put your homework up in just 1 second.